Everyone, thank you for joining us today. I'm Joshua Bay with AgensGraph. Here we are located in Silicon Valley, hosting our 5th webinar. This webinar is sponsored by Bitnine. Bitnine is the creator of AgensGraph, a multimodal graph database. The graph database is the most rapidly growing sector in the database industry, as more organizations need to handle the complexity of data to make smart decisions. The use cases vary from the knowledge graph, network infra management, recommendation engine, and so on. It is also a solid foundation for machine learning and blockchain technologies. Recently picked the graph database as a top 10 data and analytics technology. It says that the application of graph processing and graph DBMSs will grow at 100% annually through 2022. Today, our speaker is Abdisho. She is the technical engineer with AgensGraph team. Aya, would you please tell us a bit about yourself?
Of course. Thank you, Joshua, for the introduction, and welcome everyone to our 5th webinar. As Joshua mentioned, my name is Aya, and I'm a technical engineer with AgensGraph. I'm responsible for AgensGraph support and also the consultation of AgensGraph.
So Aya, what would you like to speak about today?
So today, as you see in the topic, our topic is graph modeling. So we'll be more focusing on how to do graph modeling in AgensGraph, and we're going to have a hands-on session on a specific data set, which called Nordwind, which we're going to get to that a little bit more detail later. Okay, again, welcome everyone, and thank you for being here today. So to give you a little bit overview of today's webinar, I'm going to do a little bit introduction of what we do here at Bitnine, then a little bit introduction on AgensGraph and our product, and also after that, we move on to our hands-on session. So we're going to talk about our data set that we're going to use today, and also we're going to after that start the demo. At the end, we're going to take any question that you have. So we have a Q&A section. So the chat box is open during the webinar. So if you have any question, please feel free to send your question, and we're going to get to that at the end of this webinar. Let's start it. As Joshua mentioned, here at Bitnine, we are basically the global leader of graph business solutions. Offer different services and different supports. Some of those different values that we can provide to our customers is graph database through AgensGraph, and also the capability of multimodal and the feature of AgensGraph. So we also offer outstanding performance. We have our LDBC benchmark testing, which I'm going to get to more detail into that later. Also, we provide our professional services, which includes graph consulting, feature development, graph algorithm, also big data analysis. So if you have any question regarding any services that we have, or if you have any, if you need any help or support, please reach out to us, and we'll be more than happy to get back to you. In Bitnine, we have different locations, different offices. I'm located in Santa Clara, California, and I'm with this team. We have different offices in London, UK. We have office in Seoul, South Korea, and recently we are opening our new office in Tokyo, Japan. A little bit background about myself. As Joshua mentioned, I'm the technical engineer with AgensGraph, and I've been with AgensGraph for a couple years. So we are growing, and these are my information. So if you need to reach out to me after this webinar, feel free. You can reach out to me by phone or email, and I'll get back to you as soon as possible. What I would like to do today before we deep into our topic, we get always questions regarding AgensGraph and also other softwares and tools that we offer. So I would like to share some of this question with you today. It might be your question as well. So I chose two questions. One is regarding deeply nested data properties, and the second question is regarding hybrid query examples. To the first question, this question was from our Stack Overflow. So the question is, can we have highly nested properties in AgensGraph for our vertexes or edges? And the answer is yes, unless other databases, graph databases that is out there. AgensGraph is one of the graph databases that supports this deeply nested data as a properties of vertex or edges. It's been a challenge for some people while using other graph DBs to have the same structure, same exact JSON structure as their properties. But AgensGraph support that, and you can simply just have the same JSON structure as the properties of your vertex or node. So you don't need to make any changes. You don't need to flatten your data or anything. You can just import it and have the property. Next question that we have is, so people are asking us to give them a little bit more examples of hybrid query. And you might know, or you might be new to AgensGraph, but AgensGraph has a capability of giving you the ability to have a hybrid query. And by hybrid query, it means that you can have different query languages in one execution. And so this is the reason they're asking for some examples. And if I want to show you this, I prepared a small example. It's really simple, but the idea was to just introduce you to this type of query. So as you can see here, this is two parts. So this is a graph part, and this is a relational part. In this graph part, we are making our graph, which is called AG, and then we have a vertex label called dev. And we have just some sample data here. We have 2 person, different names, and also the year. And in the relational side, we created a table named history with 2 columns, year and event. And again, we have just some sample data. When it comes to the hybrid query, we can have it in 2 ways. We can have Cypher in SQL, or we can have SQL in Cypher. So Cypher in SQL, this is a syntax if you want to follow it, but more understanding can be an example. So if you look at this example here, you can, so this one is outer query is SQL, and our inner query is Cypher. So we plug in this, and we are returning the developers maybe that we have in that graph that we just created. Then based on this, we are running our outer query, which is SQL. So as you can see, it's a hybrid query. It runs at the same time, and you can get your results. Or if you want, you can have it the other way. You can have Cypher as your outer query. Inside, as you can see, it's a select, so it's a SQL query. I'll get more in detail. I have more examples for hybrid queries in my next slides, but this was just an overview to give you an idea of what is hybrid query. So a little bit agenda today. After this, I'm going to go through AgensGraph, then introduce the Nordwind. We're going to do a graph modeling together, and at the end, as I mentioned, it's a Q&A. So AgensGraph is a graph database which is built on PostgreSQL. It supports it's a multi-model, so it supports other structures as well, such as key value, document, and relational, and as I mentioned, graph as well. So before we get to AgensGraph, some of you might be new to graph databases, so I'm just going to do a really quick introduction of graph databases, about their structure and why everyone's shifting to the graph databases nowadays. To give you a better idea, I have a slide prepared here. So in this slide that you see, we have a vertex, also we have an edge. And as you can see, it represents a graph structure. So basically, we have 2 entities, which by connecting them together, we're going to have a new structure, which is a graph. So for example, we have a vertex person. We can assume that his name is Bob. And also we have an edge, which name of it is purchases. So in this case, Bob is connected to another vertex through this edge. So we can guess that Bob is basically buying something, which can be hat, which can be clothes, any product. So by connecting and by having all those elements together, we're going to end up with the structure, as you can see in this picture, which is called graph structure. And by having this, in this specific example, we can go through different patterns and we can find out that what is Bob's basically shopping pattern. And we can understand maybe his pattern better, his what he likes better, so we can maybe start building a recommendation system, which is one of the use cases of graph DBs. This slide, what you're seeing the relational database in the left side, and you're seeing graph databases in the right side. To give you a little bit better idea of what is the differences between these two, from the structure side, all the data, as you know, in a relational is saved in a table format, and in a graph, databases, everything comes in the form of vertices and edges, and they're all connected to each other. So as you can see, as I mentioned before, we have two vertices, which is bill and eraser, and they're connected through the purchase, which indicates the relationship that these two data and entities have together. And also at the same time, each vertex or also an edge can have its own property, which is an attribute in a relational database. Always a question that why graph databases, and what is some of the advantages by using graph databases compared to relational. And if you look at this example more closely, in this specific slide, we're looking to search for a friend of Alyssa. So we know that if you want to run this query, and if we want to look for the friend of Alyssa in the relational side, everything is saved in a table format. And in this specific example, we have different tables. So one table is person, the other table is person's friend. And if you have a background in relational databases, you now know that we need to go back and forward between these two tables to find the friend of someone. And it takes time. It needs join operation, which we know it's timely and it's really. So it's not really the good option. But in a graph databases, if we have this complicated relationship and connection, much easier, and the reason is because everything is connected to each other, and instead of using join operation, we can simply avoid those, and we can go through the patterns and we can look at the connected data, and we can find all those persons or people that we want. For example, here we have Alyssa. We know that Alyssa has a relationship with Bob through this edge, so we can check if they're friends. Then we know that we need to check the friend of Bob. So it's pretty straightforward. You avoid join operation and it's faster. And even in this example, the response time of GraphDB was much better. We also ran some other tests. We went more deeper. We added more hops. So in the fifth level, as you can see, even relational database couldn't perform and the operation wasn't finished. But at the same time, GraphDB performed really good and the performance was much better. Now, as I mentioned, AgensGraph is a multimodal database. It supports document database. It supports graph, key value, and also relational, as I mentioned before. So this is just the whole idea of AgensGraph as a graph database, as a database. Now, what you're looking at here is a diagram which related to scalability, scalability to size, and also scalability, scale to complexity. So as you know, when it comes to size and also scalability, people normally tend to start talking about the relational databases. But we need, and also we know that when it comes to that, relational databases has some trade-off. And that was the reason that NoSQL databases was introduced in the market to solve some of the issues of relational. At the same time, we know that when it comes to complexity, graph databases can perform much better. It's been proven they have a better, basically, solutions and performance. And by saying that, you know that if you have all this in one place, you can have a better scalability when it comes to size, at the same time when it comes to complexity. And AgensGraph, by having this feature, basically support you through this. A little bit more about AgensGraph architecture. What you're seeing in this slide is a simplified architecture of PostgreSQL. So what our team did, what our developer did when they started building AgensGraph, we added our own logic to the different layers of PostgreSQL. And we also have our own pattern for each logic that we had to that layer, as you can see here. And also, yeah, these are the different layers. So as I mentioned, AgensGraph is built on Postgres. So that is the reason that you're seeing the architecture of Postgres. Example of hybrid query, which I mentioned at the beginning of our today's webinar. So this is a better maybe for understanding it. So if you have a relational database and also at the same time you have a graph database in AgensGraph, you can at the same time query from your relational and also graph. So this is the same structure that I showed you, but another example. So you can have Cypher and SQL, as I mentioned, or you can have SQL and Cypher. Data wrapper engine, it's AgensGraph support for a data wrapper. So it means that you have the capability of importing your data from different sources in AgensGraph and start modeling, querying, and analyzing your data. This data can be from different resources. It can be web data, it can be file data, it can be from different databases. Also, it can be big data. So it's pretty straightforward. You import your data in AgensGraph through this FTW, and then you're good to go to do the other steps. A little bit about our LDBC benchmarking that I mentioned before. I'm going to go through it more detail. To start, these are the environment that we used. The processor, memory, and total disk. This LDBC benchmark test on AgensGraph against one of our competitor, which is out there. So here is a complex queries based on that LDBC benchmark testing that we did, our team did. The orangish color that you are seeing here is AgensGraph, and the blue color is one of our competitor that you're seeing here. So if you want to take a look at one of the queries that we have here, maybe we can focus on query number 4, which in this case, you can see that AgensGraph performed better. It was something close to 2,000 times faster than the other database. And normally people ask and they guess at what is that query and how did it happen that AgensGraph performed faster and what was the reason. So for this reason, I prepared the query number 4 so we can take a look at it in more detail. Go here, that was the query number 4 that our team basically worked on it on AgensGraph on a competitor. So in this specific query, we were looking to find new topics. And by saying that, let's assume that we have a start point, which is this start person. Now, what we're looking to find tags that are attached to posts that were created by that person's friend. Now, only we wanted to include tags that were attached to those posts created within a given time interval and with that specific person, and that were never attached to friends' posts created before this interval. So by saying that, let's assume that we have 2 patterns, pattern 1 and pattern 2. In this case, we wanted to find only pattern 2, which does not have pattern 1, which does not have pattern 2. We want to exclude the pattern 2. Happened in our competitor side, they were pure graph. So we had to model this in a Cypher query. So everything is Cypher. Pattern 1, Cypher query, pattern 1 is a Cypher language, 2 is Cypher. And at the end, we basically excluded the pattern 2. Now, this query takes 2 lines because it searches pattern 2 for each occurrence of pattern 1. Now, let's assume that the number of pattern 1 is n and the number of pattern 2 is m. Then in this case, in this query, in their environment, we had n times m traversal, which it's not operation. It's a little bit expensive operation. That was took too much time. What happened in our side with our AgensGraph, because of its capability of having multimodal databases and hybrid query, we were able to write a hybrid query, which is a combination of SQL and Cypher in this case, and we use that approach. We have pattern 1 in Cypher, pattern 2 in Cypher, and what we did, we used SQL as our outer query, and we basically excluded our in this case. So what happened, this query finds pattern 1 and pattern 2 respectively, and left join them at the end, as you can see here. So in this case, instead of having 10 times m traversal, we ended up with n plus m traversal, which was much faster and more convenient in this case. Use cases of AgensGraph that we have here, which I want to go over it. One of our use cases is MDM, Master Data Management. In this case, by using AgensGraph, some of the benefits that they were able to achieve was they were able to improve research productivity through business process innovation. So they basically implemented the graph model and they benefit through that. Use case that we have here is our CTI, Cyber Threat Intelligence. Some of the challenges that we have was the continuous evolution of cyber attacks and also limited performance of the table structures data. By having AgensGraph, they were able to have an integrated relation analysis system and also real-time monitoring system, which helped them to reduce the cost through proactive detection and faster response time. Use case that we have here is our knowledge graph, personalized education service. In this use case, the need and the challenge was to develop a customized learning recommendation system, which in this case, their legacy system was the table structure, which wasn't responding really good for their purpose. What happened by using our product, they were able to build an organic learning graph model, and they were able to build a behavioral data analysis model. And they were able to introduce a new learning level diagnosis and curriculum recommendation system. The next use case that I have here is a performance management. In this use case, there was a need for a system, collaboration, efficiency. Also, the reason that they were having issue was that data was from different formats across all the multiple systems. And also it was difficult for them for a common relational data models to quickly query, process all those highly connected data. So by having AgensGraph, they were able to enable smooth communication and also quick cause analysis and response through that issue. And our next use case is our asset management use case, which also known as failure analysis and monitoring system. And this use case was for one of the power utility companies. The legacy system was all relational. All the data was saved in a table format. And the challenges, the issue they were having, that they were having issues to discover the point of failure fastly and correctly. So the accuracy was issue and also the cost was issue. So they were able to use a multimodal feature of AgensGraph and have some parts such as network topology in a graph and also log data in a relational part of the AgensGraph. And they were able to reduce the cost by decreasing that response time. So before I go and jump into the hands-on session and to the graph modeling, just to checklist that we have everything. If you don't have the Northwind dataset, if you just want to do it later at home, you just need to make sure that you have this tool and dataset. So you need to have AgensGraph, Agents Browser, and Northwind data to be able to do this graph modeling. So if you need any question, if you need any of those, please reach out to us. I will also send an email after this webinar with all this information. A little bit about Nordwind. In this graph modeling, as I mentioned, we're going to use this Nordwind data set. And this is the ER diagram of this data set. As I mentioned, it's really famous in the relational side. And now, what is this data set? This data set contains sales data of a fictitious company called Nordwind Traders, which is an importer-exporter of specialty foods from or to the global market. So in this data set, in a relational format, we had 11 tables. Now, what we did, we modeled it in graph, and I'm going to show you how to do it today. So now, as I saw you before, as you see it before, this is the ER diagram Nordwind. After our today's session, after we model it, you're going to see this as graph schema. Now, a little bit why graph. I mentioned it before, but why graph in Nordwind, why graph maybe in the business market? And the reason is that everything is connected in the businesses. Everything is connected in this words. And by having it in a graph model, because of all those relationships and connections that we have, it's much easier to discover the meaning and to discover the relationship between the data that we have. So it's the same for the Nordwind. If we model it in a graph, we can find out more about our customers, about our product, or any other information that is in the data set. Really quick, the steps that we're going to follow today. So to import the data, all the data is saved in a CSV format, in a CSV files. So for that reason, as I mentioned, we have our FDW. So we're going to import the data with the FDW from CSV files to the AgensGraph. So we have to create this extension, and then we can have the data in AgensGraph. Now, after that, we can create foreign tables, and we can save those data to the foreign tables. So after that, we can start creating our vertexes and edges. So there were 3 steps: importing data, creating tables, and also after that, what we're going to do, we're going to create our vertex and edges to have our graph. And this is what you're going to see at the end when you're finished with your model. After that, what I'm going to do, I'm going to run some queries in our visualization tool, which is Agens Browser. So, which is an environment you can query, you can analyze, and you can see your data as you can see in this picture. So it's a visualization tool, and we're going to get to that as well. Also, I'm going to show you how to update your graph after you finished it, in case you want to go change some information. Yeah, now is the demo section. So bear with me until I just switch my environment a little bit. So this is my CLI, and I already prepared some queries to make it a little bit more efficient and for your readability. So you can see it, you can follow me. I'm going to provide all these queries and all this information after this webinar. So please do not worry if you're not following now, you can always have it. Okay, so as I mentioned, the first step in this case is importing our data from CSV files to AgensGraph. We need to have the FDW. So the first step, we're going to create our extension. So this is the command for it. So we can go to our CLI. And we need to create a database. So you can just use create DB. I'm going to call it AgensGraph or Nordwind. Nordwind D. We can go to our Nordwind DB. I'm showing you all the steps that you can follow. There you go. We are in our database in AgensGraph. Now, our first step, as I mentioned, we need to create the extension. So, sorry, I didn't copy it. So we go here. And there you go. If you see this prompt, it means that your extension is created. So it's a FDW extension, and you're good to go. Next step is to create a database connection server, which is line 6, this command. So you create server Nordwind foreign data wrapper file FDW. So this is the name. It can be anything. In this case, I just name it Nordwind, more relative. But at the other one, you need to keep the same structure. There you go. And if you see this, it means that you have your extension, you have your server. Now it's time to create our foreign tables and import the data to those tables. Now, as I mentioned, we have 11 tables in Nordwind, so we need to create 11 foreign tables. So I'm going to go through some of them to give you a better idea. So with this, you can say create foreign table, the table name, obviously. Then you can have your columns here. So it's the same as the CVS format. So to just show you maybe a little bit some of the CSV that we have to give you a better idea. So this is one of them. For example, you have different columns and different information. So same is here. You can have the same columns and you need to just give more information, like what is the data type of that specific. Now, after that, the most important part is here. You need to be careful here. You need to tell the server that what is the format of those files. So in this case, as I mentioned, it's CSV. Then after that, here is where you give the path to that CSV file. So AgensGraph can reach out to it and get the data. So in this case, I have it in my AgensGraph folder, and this is a category that's CSV. So this is again the path, and by running this, you should be able to create your graph. So create the table. So if you see this, it means that you're good to go. You create your table. It's the same process for all the other 11 tables. I'm just going to go over one more, and I'm just going to move on to the next step. So in this case, we have our other table, which is called customers. Again, different columns, different properties and attributes. Then again, format CSV. And the reason we need to specify it is because it can be other formats too. It can be text, it can be other file formats. So you need to specify that which one you're looking. And also this is the path to that specific file. So if we run this, we have our tables. So it's, as I mentioned, it's the same process. So I won't explain the name. It's the same. So what I'm gonna do, I'm just gonna copy the other tables. And there you go. This is our last table. As you can see, it's 11, which is territories. So it's the same as the other ones. So I'm just copy and paste it, and there you go. So if you see these messages, it means that everything's fine. Just in case, if you want to make sure that everything is there, we can check to see if we have the 11 tables. So what we can do, we can run /D, and there you go. We have the 11 tables that we wanted. It's created in AgensGraph. Our next step, step 3, is to create a graph. So you can use this command, create graph, and the name of the graph that you're looking for. So in this case, I name it Nordwind_graph, but you can have any names that you want. So I run this command. Sorry, a little more. So create graph, and there you go. We have our graph. Now, next step is if you want to make sure that you have it, you can use this, and you can see the list of the graphs that you have. As you can see here, it's a list of graphs. So you need to know that in AgensGraph, in one database, you can have different graphs. So we can have multiple graphs, and if specific graph, you need to say that to AgensGraph. You need to mention it. For this reason, you need to set your graph path to that specific graph that you are looking to use, which in this case, we're looking to use a Nordwind graph. And if you see the set, it means that we are good to go. We are in the environment of our graph. Now, after that, our next step is to create our vertexes. And for this, if you look at this, the one that I highlighted, we need to use the load command. So we load from the foreign table that we created, in this case is categories, and we load it as a source. Then use the create command to create our vertex, which is category, and we pour the data, we save the data to the category from the source, which was the foreign table category. So we run this. You can see we create 8 vertexes. The same process for the other one. I'm just going to explain one more. So this is a foreign table customers. we are saving it as a source. We use the create command to create vertexes, which is customer in this case. And we are getting the data from that table. We are saving it in the customer vertex. So as I mentioned, the same process, we can just copy and paste the rest. So you can see that these are the vertexes 9, 4, 26, 53. Now, to make sure that we have all the vertexes, what we can do, we can check to see if we have everything with this command. So D, uppercase G, and V will give us the list of the vertexes. So if you go a little bit up, this is the vertexes that we just made. As you can see, the labels that we just made, V labels. And these are more like detailed information, but if you want to see the list, you can just a little scroll up. And now, our next step is to create indexes for the vertexes that we want. So in this specific example, I'm making the indexes on the IDs of those vertexes. So we have category ID, customer ID, employee ID, and as I mentioned, it's all IDs. Now here we are making only a single index, but if you want, you can also have multiple indexes on the different properties. So if you need more information, reach out to me, I'll get back to you. But in this example, we are just doing it on the ID, one property. There you go. So if you see create property index, it means that all the properties are created. Now, our next and last step in creating our graph is to generate edges among our vertexes. So these are the process, and I'll start from this one, and I'll get back to this later. So in this case, what we're doing, we are matching from two employees. So we are saying we're trying to match between two employees, and we are trying to make a relationship between those two employees. And this is our condition. So we're saying if or where m.employee ID is equals to n.report2, create this relationship. So basically, we're trying to find out that who's reporting to who, so we can create that relationship. So by saying that, we run this. And if you see that it inserted any edge, it means that you were successfully create the edges between the employees. And you specified who's reporting to, or whose manager is responsible for the reports. Now, it's the same for the other ones. We only have two different commands for two of them, and that's why I left it for the last. So I'm going to explain that. The reason that you're seeing it a little bit different is because instead of matching between those two vertexes you saw in the previous example, in this case, we are using a join table. We are using a table called order details, and we are matching between those two vertexes by reaching out to that join table to see if they have any common. If they have, then we're going to create the relationship. So it's the same concept as the join tables in a relational. So the reason I chose this, I wanted to show you that you can do it either way. So it's up to you. You can use it this way. You can have a third table. It's flexible. In this case, we are loading from this orders table as a source. We are matching between order vertex and product. And we're saying if the order ID is matching the order ID in that join table, and also the product ID is matching the product ID in that join table, now create the relationship between them. Also, in this example, we create a relationship, but while creating relationship, we also giving properties to that relationship. So as I mentioned, like vertexes, edges can have properties as well. And this is what you're seeing. So same concept. I'm not sure if I ran it before, but yeah, there you go. So we have 2155 edges created. So it's the same process. So I'm just going to copy and paste the rest. This is the same thing. We are loading from a third join. So we have 5349. Again, to make sure that you have everything, we use \DDE. And again, these are detailed information. So these are the list of the edges that we made. So it is in order, part of, and all the we want. Now our graph is created, and so let's check it out. For this reason, we're gonna move and go to our visualization tool, as I mentioned, called Agents Browser. And as you can see that the graph is already created. So I'm just gonna put it visualization. There you go. So there you go. This is the same graph that I showed you before. So it's the same structure. We got it, we built it, and we're good to go if we wanted to do any query, any analyzing, and any application that we want. So in Agents Browser, as you can see your graph. You can see the more detailed information regarding your graph. If you go to this left side of the Agents Browser, you can see the edges and nodes that you have. You can see the size of that, and also you can see the name of specific edge or node. On a specific vertex, you can also look at the information regarding it, such as label volume, size, and the name. Same for the edges, it's the same process. Let us move on to the graph section of Agents Browser, which we're gonna run some queries to show you how it works. So for this reason, I prepared some queries. So this first query that you see here, we are basically looking and trying to return customers with their orders, and also the product or products that they bought in that order. So you can see that this is a 3-degree relationship, returning it as a path. So but you can copy and paste this, and you can paste it here, or you can just type it here if you would like. So if then you're gonna hit the run, and you'll see your results here. And so what you can do here, Agents Browser also can give capability of laying them out in a different format. So what we can do here, we can have a layout like that. So as you can see, you see this 3-degree relationship. And yeah, so this is our first query. Now, our next query, I'm just going to move here. Next query is query number 2, which in this case, we're looking for a specific customer, Anton, and we're looking to return Anton's order, the product that he bought, and also the category of the product that Anton bought. And the reason we are returning these results is to find out that what is his shopping pattern, what is his most bought product during this time that we have in this data set. So maybe we can go and recommend them same product. On this query, these are the information. So we can, again, different layout because it's 3 degrees. So I'm just going to use the relationship. One thing about it here, you can change the color of your vertexes if you want. I'll do a different color. And so yeah, there you go. You can see this is the Anton, and these are the orders and the categories that he bought. If you can see, I just noticed that he bought mostly from the beverage. So his orders was mostly focused here. So we know that he's mostly shopping from the beverages. So now we know this information. What you can do if you want to see any other information regarding, let's say, customer, you don't want to see the name, maybe you want to see his company name, you can click on that, and instead of Anton, it will give you other information. So you can have different properties showing in this environment. So it really depends on what you're looking for. Okay, our next query that I prepared here is query number 3. We are looking to return the entire supply, order, and sell data of a specific product called chai among many other products. So for this reason, we can just copy and paste. As you can see, these are different paths, 1, 2, 3, and you can return it all together. I'm gonna move on here. We can clean this. And by running this, see that you get all this information here. Now, let's use a different maybe layout so you can be more more familiar. So there you go. We have the product chart that we were looking for, and we have the orders, we have the supplies, and all the information regarding that specific product. This is what we're looking for, and we got it working. Now, our next query in this case is query number 4. In this query, we are looking for a specific employee who is a salesperson, and his name is Steven. So what Steven is responsible to, he's responsible to basically make sales for the specific product. Now, in this case, he has 2 options. He can make direct sales, or he can also go through his manager and then make the sale. So which is not a direct sale. So in this case, we are looking to see if when Steven sold the specific meat, if it was a direct sale or if it wasn't a direct sale. This reason we have this query. We're gonna run it here. Running this. So maybe we can use a different layout here. And what we can do now, we can use the shortest path feature of the browser, and we can start from Steven, which in this case we can change the name of the color of the Steven so we can see it. There you go. So this is Andrew. I think Steven is here. So we go to the shortest path. We start from Steven, and we go to the product that we're looking for. We start from Steven. We go to the product that we're looking for. If we hit search, we can see that this is Steven. He went through this, and this is the product. So this is the path that he made when selling it. So there's no relationship with Andrew, which is his manager. So we can confirm that he made the direct sell. And the last query that I actually promised you was to update your graph. So in this specific query, we have a customer called, not a customer, employee called Janet, who is reporting to her manager, which can be anyone. So we don't know who, but what we're trying to do, we're trying to change that direction, change the relationship. So Janet now needs to report to a new manager, which let's say his name is Sam. So and his employee ID is 5, as you can see it here. So what we need to do, we need to remove that relationship, the relationship that Janet has with her previous manager, and we need to create a new relationship from Janet to the new manager with the employee ID 5. So in this case, we match that employee, then we're gonna match the Janet's and whoever she's reporting to. We're gonna delete the relationship, and we're gonna create the new relationship. So we can just run this all in one time. And if we do that, so there you go. You can see that the removal is already affected, and we're good to go. Now to check that, what we can do, we can match to see if now Janet's reporting to employee ID number 4, which is a new manager. What we can do, we go here, we run this. There you go. This is Janet and Steven. So we can check Steven's employee ID is 5. So as you can see, the update was created and everything is fine. One more thing I want to mention, in AgensGraph, we can also use procedural languages. So if you go to PL editor, you have the capability of write function in the different languages, such as PL Python U, PL PG SQL, and SQL. So in this case, what we have, we're trying, this is a really simple function to just show you that Agents Browser have this capability as well. So we're looking to return the customer's name. So you can just create a function here, name, choose a language, return type of it, and you create it here, and you. So we'll do it together. So this is our function body. So we can just copy and paste it here. We can give it a name. Let's say name, customer name, language via Python. Can say this is return type as text. You save it, and there you go. Do you see it's already here, and it said is successfully affected. So what you can do, you can go back to your graph query environment, and you can call your function here. So you do select customer name. It's a simple function call. You run it, and the information will be in the table tab of Agents browser. So you go here, you click on this, and all the names are here. You can copy it anywhere that you want. So yeah, that would be all for today. And thank you for listening to us. Now we're gonna go to our Q&A section. There's still time, so if you would like to ask any question, please feel free to send it to our chat box. Second, until I look at some of the questions. So one of the questions that I got here is, what is some of the AgensGraph drivers? Which one you guys are supporting? So we mostly supporting like all of the main languages such as Java, Python, Golang. We have Node.js, and this is what I'm remembering so far. But if you're looking for a specific driver, please reach out to us. We'll be more than happy to help you with that request. So next question, what are some of the deployment options for AgensGraph? So this is a really good question. We are on cloud, AWS. We have our Docker image. You can build AgensGraph from GitHub or source code. And also we have binary packages ready on our website for the different operating systems. If you're looking for a specific way of deployment, reach out to us and we'll help you with that. And yes, you can. Another question, as I mentioned, because AgensGraph is built on PostgreSQL, another question that we have, can we use all the extensions with AgensGraph? And yes, because it's built on Postgres, you should be able to connect easily and use other extensions of PostgreSQL. Would be all. Again, thank you all for joining us and listening to us. Feel free to reach out to us. I'll be sending you all the queries and whatever I used in this hands-on session, so you can try it if you want. Thank you, and have a great day.